Okay, hello and welcome sa recording ng ating lesson about transformation by trigonometric formulas. So, yung main objective natin for this topic is know and use correctly the transformation by trigonometric formulas. So, well, itong topic class na ito, so madali siyang maintindihan kasi may mga types po siya, no? So, meron tayong four types na pag-uusapan under this topic. And kapag natutunan nyo na po yung four types na yon, so yun na po yung pinaka-lesson natin na transformation by trigonometric formulas. So sa type 1, basically ang makikita nyo po sa loob ng integral sign, yung integrand natin ay sine and cosine, no? Walang ibang trigonometric function na involved dito, sine and cosine. Kaya lang, yung exponent nila, itong m saka n, so magiging type 1 siya. So if yung m or n is a positive odd integer. So, kahit isa lang dito sa sine and cosine na merong odd number, so under type 1 na yan. Or even kahit walang sine, andyan si cosine, pero add yung kanyang exponent, odd number, so type 1 yan. Or, halimbawa, walang cosine, nakikita mo si sine, pero naka-add numbers yung kanyang exponent, this is also type 1. Yan yung characteristic ng type 1. So, at least isang exponent is odd integer. So, pag napansin nyo na ganun po yung integrand natin, ito na po yung magiging solution. You're going to use sine squared x equals 1 minus cosine squared x. So, this is a trigonometric identities. And also, cosine squared x equals 1 minus sine squared x. So, let us consider this example. What is the integral of sine x to the fifth power times cosine x to the third power dx? So, again, at least isa is odd number type 1. So, pero to, paano? Dalawa siya. So, ibig sabihin, kahit alin dito is pwede natin gamitin as our solution. So, by the way, paano ba sinusolve? Una class, kung odd number, kailangan nyo mag-separate po ng isang trigonometric function, either sine or cosine, depende sa kung alin yung odd number. Isi-separate nyo po yung raised to 1. It means pwedeng cosine x or pwedeng sine x. And what is the purpose of that? Bakit kailangan nyo po na ihiwalay siya? Kasi po siya is gagamitin natin as derivative. Okay? So example, dito tayo sa cosine cube x. So since odd number yan, yung isang cosine, i-separate natin for the purpose of derivative. Syempre, may matitira pang cosine squared x. At ito naman, meron pa tayong sine x to the fifth power. So, pag na-separate na natin yung isang trigonometric function for the purpose of derivative, so dapat po, isipin natin, ano ba dapat yung matitirang function dito? Kasi may derivative kang cosine. So, simple lang ang sagot doon, di ba? So, ano bang trigonometric function yung merong derivative na cosine? O, di ba? Sine lang naman yon. So, ibig sabihin, kung may natira pa ditong cosine squared x, so it means kailangan alisin mo to, gawin mo tong function of sine. Kaya, dun mo magagamit yung identities. Kasi yung cosine squared x is just 1 minus sine squared x. So, ipa-plug in natin yan. O yan, naging function of sine na. Again, ito ay yung magiging derivative niya. So, sine x to the fifth power times 1 minus sine squared x. So, just distribute. We have now 1 times sine x to the fifth power is sine x to the fifth power minus sine squared x times sine x to the fifth power is sine x to the 7th power. And then, pagdating dito po, class, isi-separate natin, pwedeng paghiwalayin muna o kung na-identify nyo na ito po is just a power formula because yung sine, ang derivative ay ito. So, pwede na tayo mag-add ng 1 dun sa exponent. O kung isi-separate natin, we have sine x to the fifth power times cosine x dx minus sine minus the integral of sine x to the 7th power times cosine x dx is simply, this is a power formula kasi yung pong sine, ang derivative niyan ay cosine. So we don't need a neutralizing factor kasi exact po siya, no? Eksaktong-eksakto yung kanyang u du. So automatic mag-add tayo ng isa sa exponent. And that's it. We have now the integral. Okay. So ngayon, paano kung doon tayo sa sine? Kasi add number din naman yan. Pwede rin po yun. Ang mangyayari, itong sine x to the fifth power, since odd number, pwede tayo maghiwalay ng isa. Sine x, again, the purpose of this is derivative. So, it means kung ang derivative ay sine, ano bang trigonometric function yung may derivative na sine? So, walang iba kundi cosine. So, dapat lahat po ito maging function of cosine. So, yung sine to the fourth power, papalitan po natin siya. Identities tayo. So, ano bang identities na yung sine x to the fourth power? So, well, para magamit mo siya, dapat meron kang sine squared. So, kaya yung sine x to the fourth power is pwede natin gawin na sine x or sine squared x raised to 2 or squared. And that's it. Yung sine squared x is pwede nating gamitin yung identities na 1 minus cosine squared x. And if we expand this, no, pag in-expand po natin, we have 1 minus 2 cosine squared x plus cosine x to the fourth power times sine x dx. Then, yung cosine cube x, so pwede nating i-distribute yan sa loob, o i-multiply natin isa-isa, we have this, no? And pagkatapos plus nito, ayan, pwede natin na siyang i-integrate. But, tingnan natin, ito ay c or cosine po yan. Remember, kapag cosine, ang derivative po niyan ay negative sign. So, pag ganito po, ang concept is very simple. Papalitan nyo lang yung sign. So, and then, add na lang tayo ng 1 dun sa exponents. Kaya dito, we have negative cosine x to the fourth power over 4. This is magiging positive na kasi may negative ng dati. And since yung 5 dadagdagan natin ng isa, magiging 2 over 6, i-simplify na natin, that is cosine x to the 6th power over 3. And then this is minus cosine x to the 8th power over 8 plus c. And that's it. May sagot na po tayo. So, in other words, kapag parehas add numbers, you have an option kung alin po yung gagamitin nyo. Pero syempre, kapag add number parehas, ang madali doon, yung mas mababa. Syempre, yung, alin ba, yung mas mababa, no? Yung mas mababa na ano natin, na exponent, doon ka kukuha. Huwag doon sa mataas, no? Kasi nakita natin, pag dito tayo kumuha sa mataas, so, mas mahirap po yung, hindi naman siya mahirap, pero mas mahaba yung magiging solution. Yun lang naman po yun. Example, halimbawa, bigyan ka ng sine x raised to 7, saka cosine x raised to, let's say, raised to 3. O, doon ka sa raised to 3 lang, kasi yung 7 masyado ng mataas yun. Okay, this is type 1. Again, in our practice problem number 1, so ito po yung ano natin problem. So evaluate the integral of sine cube x times cosine x to the fourth power dx. So pwede nyo i-post yung video para dun sa hindi pa nakapag-solve, i-try nyo pong sagutan. Ngayon, kung ready na kayo, pwede nyo nang ituloy yung panonood. So ang magiging solution class natin dito is simply, since may odd number tayo dito, kailangan nyo pong ihiwalay yung isa, no? Yun po yung solution. Again, the purpose is for derivative. Then, after that, yung natira dito is sine squared x times cosine x to the fourth power. Again, sine x dx is derivative, so dapat maging function of cosine yung natitira dito. So, meron tayong sine squared x. So, therefore, we're going to use trigonometric identities, which is 1 minus cosine squared x times cosine x to the fourth power, sine x dx. Then, itong cosine x to the fourth power, i-distribute lang natin siya dito. So, we have now cosine x to the fourth power minus cosine x to the sixth power times sine x dx. So, again, ang sine x dx, ang pinaka-purpose niyan is yung derivative. At remember, ito po is c. So, magpapalit po tayo ng sign. In this case, pwedeng paghiwalayin or pwede pong i-integrate na kasi madali naman yan. This is just a power formula. Mag-add lang tayo ng isa sa exponent. And don't forget to change the sign kasi yan po ay letter C. Negative ang kanyang derivative. So, kaya magiging just add 1. We have negative cosine x to the 5th power over 5 plus cosine x to the 7th power over 7 plus c. Or pwede nating interchange, unahin yung positive. Yan na po yung magiging solution. So, for our example number 2, we have evaluate the integral of sine x to the 5th power dx. So, pwede po yun na isa lang po yung given, walang cosine. Wala namang problema yan. Mas okay nga yan kasi iisa lang yung i-consider natin. So again, add number, kailangan yung ihiwalay yung isa. At yung natira, para magamit mo yung identities, dapat meron kang sine squared. Kaya yung sine x to the 4th power, gawin natin sine squared x raised to 2, so that ito po is, ang identities is 1 minus cosine squared x raised to 2 or squared times sine x dx. Then expand, no? Pag in-expand natin, this is the expansion. And then pagdating dito po, no? Pagdating dito, since this is just a power formula, itong dalawa, pwede nyo na pong integrate yan. Or, kung gusto nyo pong i-distribute muna itong sin x dx, so dito po sa tatlong terms, so we have the integral of sin x dx minus the integral of 2 cosine squared x sin x dx plus the integral of cosine x to the fourth power sin x dx. Again, for the solution, pwede naman siyang i-direct kasi yung integral ng sin x dx is already negative cosine x. Kung may formula na tayo dyan. So, dito naman po, sa negative, we have the integral of 2 cosine squared x sin x dx. Tingnan natin yung cosine, ang derivative po is sine, di ba? Nakikita na natin yung derivative o yung constant, pwede naman siyang ilabas. So, mag-neutralizing factor tayo ng negative sign kasi yung cosine, ang derivative dapat negative sign. I-positive yun nakalagay. So, therefore, kung may negative sign, so we need to change this sign. So, from negative, so magiging positive na yan, 2 cosine cubed x over 3 kasi plus 1 lang doon sa exponent. And then, pagdating dito naman, so again, derivative ng cosine is just negative sign, positive, so mag-neutralizing factor, just add 1 to the exponent. Or, kung gusto nyo pong i-rearrange, unahin yung positive followed by negative sign, that is also okay. And that's it. Ganun lang po yung type 1. Hindi naman siya mahirap maintindihan kasi based lang tayo dun sa exponent kung merong odd number. Then mag-separate ng isa for the purpose of derivative. At yung natira po, doon na po tayo gagamit ng identities. And commonly, ang nagiging integral po niyan is commonly power formula or pwede rin na integration of trigonometric functions kung mag-isa lang po yung trigonometric function na involved. Okay? So, and that's it for type 1. Sa type 2 naman po, ganun pa din. Yung ating integrand is still sine and cosine. Kaya lang, ang kaibahan class dito, yung kanyang exponent ay parehas even integers. Yun lang, even integers. So pag ganito po, ang identities na ginagamit is iba na po, no? Iba na. So, yung sine squared x is equals to 1 minus cosine 2x over 2. And we have cosine squared x, which is equals to 1 plus cosine 2x over 2. Yan na po yung identities na gagamitin natin. Umpisahan natin sa integral ng sine squared x. So again, wala siyang direct integral. Otherwise, gamitan natin ng identities which is 1 minus cosine 2x over 2. Kaya ipapalag-in natin. And pagdating dito, i-separate natin. We have the integral of 1 half dx minus the integral of cosine 2x over 2 dx. And then pagdating dito, again, yung constant, pwede naman niyang ilabas. Yung constant na over 2, 1 half, pwedeng ilabas. Then, actually, pwede na siyang integrate, no? Kasi yung dx, ang integral lang niya is x times 1 half. That is x over 2. O, dito naman, ito kasi yung detailed solution, no? Pero kung kabisado nyo na kasi yung pag-integrate, kahit hindi naman gawin to. Kasi basically, di ba, pag nag-integrate tayo ng trigonometric function, so we differentiate the angle, 2x, no? Dapat nakikita natin sa loob. So yung 2x, ang derivative niyan is 2dx. So wala ka naman nakikitang 2dx dun sa given. So we need to multiply by 2 para magkaroon tayo ng derivative. And then we need to multiply by 1 half. So as in neutralizing factor to make it balance. So, therefore, yung integral ngayon ng cosine 2x dx, eto na, nakikita mo na yung derivative ng angle. So, at yung cosine 2x naman is, di ba, may integral naman yan. And that is simply sine 2x, no? Positive po ang integral ng cosine 2x. So, kaya yung negative, retain po siya. Since dating may 1 half ka na, naggamit ka pa ng neutralizing factor na another 1 half. So, 1 half times 1 half is simply 1/4. So, ito na po yung magiging answer. Okay, so again, this is type 2, no? So, integral of sine squared x dx is simply x over 2 minus sine 2x over 4 plus c. Kung kaya niyo pong i-memorize to, pwede naman po yan kasi applied po yan pagdating sa ganitong type. Kasi minsan, pag pataas na po yung exponent, pagdating sa dulo na nakita mo na meron ka pang sine squared x, so ito na po yung isasagot mo. X over 2 minus sine 2x over 4 plus c. Okay? Paano kung cosine squared x? So, same lang naman yung process. So, ang kaibahan lang yung identities niya. So, which is 1 plus cosine 2x over 2 dx. So, i-separate natin isa-isa. We have the integral of 1 half dx plus the integral of cosine 2x over 2 dx. Then again, yung integral ng 1 half dx is just x over 2. So, dito po ang kaibahan lang is plus. Kasi yung cosine 2x, again, man-neutralizing factor din tayo ng 1 half. So, magiging sine 2x over 4 pa din. So, halos parehas lang siya nung integral ng sine squared x. Ang kaibahan, So pag cosine po is positive. Okay, so ito na po yung meron sa ating example number 2. So sa example number 3, what if we have the integral of cosine x to the fourth power dx? So medyo mahaba-haba na po yung magiging solution natin kapag ganito. Well, sa start, so kailangan natin magamit yung identity. So yung cosine x to the fourth power, gagawin muna natin na cosine squared x raised to 2 dx. Then, gagamitin natin yung identities. Pag cosine po is 1 plus cosine 2x over 2, then naka-squared po yan. Pag in-expand natin, syempre, so we have 1 plus 2 cosine 2x plus cosine squared 2x over 4. Then, pwede na natin siyang integrate isa-isa. We have 1/4 integral of dx plus 1/2 times the integral of cosine 2x dx plus 1/4 times the integral of cosine squared 2x. By the way, itong naunang dalawa, pwede na itong i-integrate, no? Pwede na sana nating sagutan, pero yung kasing nasa dulo, yung integral of cosine squared 2x dx, di pa pwede yan ma-integrate kasi naka-raise to 2 pa siya. So, gagamit tayo ng another identity. So, well, yung identities po, since nasa format siya ng even number exponent, gagamitin pa rin natin yung kanina, no? Ito kung maalala nyo po kanina, ito pa din. Pag cosine squared x, so 1 plus cosine 2x over 2. So, kung yung angle dito, let's say naging 2, o i-double mo lang din dito. Okay, baba, cosine squared 2x, i-double mo to, 1 plus cosine 4x over 2. Yung angle lang po ang i-double, no? Hindi naman yung constant. So, ganun po yung mangyayari. Kaya, yung cosine squared 2x dx is simply 1 plus cosine 4x over 2 yung kanyang magiging identity. So, pagdating dito, pwede nating i-distribute yung may 1/2 tayo, di ba? 1/2 times 1/4 is 1/8. Yan. And then, 1/4 times 1/2 is simply 1/8. And then, the integral of cosine 4x. So, pagdating dito, pwede na po siyang i-integrate, no? Di ko lang siya in-integrate muna. Okay? Dito, yung integral ng cosine 2x dx is simply yung derivative ng 2x is 2 dx, neutralizing factor of 1/2. Ito, okay na to. Dito naman, again, derivative ng cosine ng 4x is 4 dx, so neutralizing factor of 1/4. So, pagdating dito, yes, pwede na siyang gamitan ng formula. Integral of dx is just x, so times 3/8. So, integral of cosine 2x to dx is simply sine 2x over 4, kasi 1/2 times 1/2. And here, so we have also, ito nakita natin, so 1/8 times 1/4 is 1 over 32. Integral of cosine 4x, 4 dx is simply sine 4x. Okay, and that's it. So, napansin natin, kapag ka-even number, medyo, na siya, mahaba-haba na yung solution. Lalo na kapag ka-raised to 4. So, well, hanggang raised to 4 lang po tayo. Kasi pag raised to 6, mas mahaba pa po dyan yung magiging solution. So, ayan, okay na po tayo dyan. So, type 3 is, iba naman po pag type 3. Pag type 3 kasi, ang given is only ito lang. Tangent x to the n power dx, or we have cotangent x to the n power dx, where n is an integer. So, yun lang po ang condition. So, it means, pag sinabing type 1, type 2, type 2, sine and cosine lang yun, add, even lang yung pinag-uusapan doon. Kapag may add na is kahit isa, that is type 1. Kapag parehas even, that is type 2. Pero pag type 3 po, yung integrand po natin is simply tangent and cotangent. So, wala tayong problema sa exponent kung add or even. Basta tangent and cotangent na naka-raise sa integer. So, integer, so ibig sabihin po niyan, add or even. So, pero hindi pwedeng negative, no? Okay, hindi pwedeng negative. Dapat is positive. So, pag napansin niyo po na tangent and cotangent yung nasa loob ng integral sign, tapos naka-raise sa integer, let's say naka-raise to 3, naka-raise to 4, raise to 5, raise to 6, etc., ito na po yung solution. So, we have these trigonometric identities. 1 plus tangent squared x is equals to secant squared x, and we have also 1 plus cotangent squared x is equals to cosecant squared x. So, ito yan po yung ginagamit na identity. So, ngayon, umpisahan natin dito sa example number 1, evaluate the integral of tangent x to the fourth power dx. So, ano bang mangyayari kapag ka-even number, no? So, sabagay, walang problema kung add or even. Titingnan lang natin yung kaibahan. Pero, sa umpisa, ano ba yung concept? Okay, ang pinaka-concept niya, class, is kapag ka uh, type 3, ang una mong gagawin is dapat po magamit mo yung identities. Dapat magamit mo yung identities. So magagamit mo lang siya kapag meron kang tangent squared or secant squared or cotangent squared, di ba? So yun. So ibig sabihin, kung tangent x to the fourth power, ang main objective mo is magamit mo yung identity. So therefore, yung tangent x to the fourth power is gagawin mong dalawang tangent squared x. Dalawa, ipaghihiwalay mo sila ng ganito. Hindi yung tangent squared x na naka-raise to 2. Hindi po yun. Kasi dito po, isa lang muna yung gagamitin mo. So it means kung meron kang to the fourth power, yung isa po, gamitan mo muna ng identities. Okay, example, yung isa po, palitan natin ng identities niya, yung tangent squared x, di ba? Pag nag-transpose tayo, we have secant squared x minus 1. O yun. Pag napalitan mo na siya, ang gagawin mo po is i-multiply mo muna siya. I-multiply mo muna. Okay? Hindi po pwedeng sabay na gamitan ng identities. Wala pong magiging solution yan. So, sa una, isa lang muna. Then, i-multiply mo muna. Pag na-multiply mo, we have tangent squared x times secant squared x dx minus we have tangent squared x times negative 1 is also tangent squared x. Ngayon, yung nauna pong class, if you observe, once na mag-combine ang tangent to the nth power and secant squared x, anong formula? Okay, that is a power formula. Diba? Kasi yung tangent, ang derivative niyan ay secant squared x. So it means may solution na. Ngayon, may natira ka pang tangent squared x. Anong gagawin? Again, identities ulit. Yan. Gagamit ka ulit ng another identities. And that is, gamitin mo ulit yung secant squared x minus 1. Bakit? Kasi wala ka namang makukuhang integral kapag ka tangent squared x. Unang-una, wala yan dun sa list ng ating mga formula. Yung ating previous lesson, so wala po yan. Doon sa integration of trigonometric functions, wala din yan. So it means the only way to integrate tangent squared x is to use its identities, which is secant squared x minus 1. Pag ginamit natin siya, so ito na po yan. Pwede natin paghiwalayan. Don't forget, may negative sign. So we need to change the sign, no? So kaya ito, magiging integral of secant squared x dx. So negative is magiging positive po siya. So ngayon, pag in-integrate natin, ito power formula. Bakit? Kasi yung tangent, ang derivative, secant squared x dx. So ibig sabihin, add 1 lang sa exponent. Integral of secant squared x dx is formula. Di ba? Ang integral niyan is simply tangent x. Yan. Formula na yan. And integral of dx is another formula that is x plus c. So, yun na po yung solution natin sa type 3. Okay. Kumusta kapag add number? Okay. So let's say add number. Evaluate the integral of cotangent x to the fifth power dx. Again, ang unang gagawin is mag-separate po muna ng isang raised to 2. Ang pinaka-purpose ay isa lang para magamit natin yung identities, no? So, ibig sabihin, kahit isa lang na cotangent squared x kung raised to 5, yan. So, again, ang gagawin natin dito is papalitan natin to ng identities, which is cosecant squared x minus 1 dx, saka natin i-distribute siya. So, we have now the integral of cotangent cube x times cosecant squared x dx minus the integral of cotangent cube dx. Again, yung pong cotangent cube dx times cosecant squared x dx is may integral na po yan. Bakit? Kasi again, yung cotangent, ang derivative po ay negative cosecant squared x dx. So it means this is just a power formula with a neutralizing factor of negative 1. Kaya okay na tayo dito. Pero kumusta si cotangent cube? Again, isang cotangent squared po yung kailangan natin ilabas kasi wala pong integral yan. So ibig sabihin, pagdating po dito, meron tayong makukuha pang cotangent squared x, may matitira pang cotangent x dx, at yung cotangent squared x is merong identities na cosecant squared x minus 1 times cotangent x dx, then i-distribute ulit, paghiwalayin, we have now the integral of, unahin natin yung cotangent x, followed by cosecant squared x dx, we need to change the sign kasi may negative sign sa unahan, we have now the integral of cotangent x dx. And that's it. Pag tinignan po natin, based in our previous lesson, so mapapansin natin na yung cotangent, ang derivative ay negative cosecant squared x. So therefore, this is just a power formula. So mag-a-add tayo ng isa sa exponent, tapos maglalagay tayo ng neutralizing factor na negative 1. The same with the integral of cotangent x cosecant squared x dx. Yung cotangent, ang derivative is negative cosecant squared x dx. So meaning, so we have a neutralizing factor of -1. Just add 1 to the exponent. So from cotangent x, so magiging cotangent squared x over 2 and change the sign. And yun naman cotangent po, if you remember, meron na po yung integral under logarithms. And that is natural logarithm of sin x plus c. Ngayon, kung sakaling nakalimutan nyo po, pwede naman kayong gumamit ng simple identities na yung cotangent x is just the ratio of cosine x over sin x. And if you differentiate the denominator, yung sin x sa denominator, ang derivative ay nasa numerator, cosine x dx. So, di ba, yun yung natural logarithm. So, yung type 3 po is ganito lang po yung ginagawa. Okay, so madali lang po siyang intindihin at dapat po dito is kabisado nyo na po or alam na alam nyo po o you have a mastery dun sa mga previous lessons. Kasi po yung nagiging last part ng solution dito is based dun sa ating mga previous lessons. So start lang, sa simula lang, yun po yung pinaka-lesson natin. Transformation by trigonometric formulas. Kumbaga, tinuturo lang dito yung techniques kung paano mo siya may integrate. Gagamitin nyo po yung rules dun sa types. Okay. Sa type 4, ang involved naman ay tangent x to the m power times secant x to the n power dx, or pwede rin po na cotangent x to the m power times cosecant x to the n power dx, where n is a positive even integer. So, dito po class, merong right combination, no? Kumbaga, may right partners na tinatawag. Kapag ka-tangent, dapat ang ipapartner mo secant, okay? Kapag ka-cotangent, ang ipapartner mo ay cosecant. Hindi pwedeng iba yung makita natin dyan. Example, tangent x, tapos tinabihan ng cosecant. Hindi pwede. Para maging type 4, dapat ganito. Tapos yung n, nakalagay dito, dapat even. Even. Dapat ganun po talaga. Kasi pag naging add po yan, hindi naman type 4 yan. Iba po yung magiging solution natin. Wala pa yan dito. Sa type 4, yun lang ang tatandaan nyo. So tangent secant, yung secant lang ang binabantayan dito, dapat even integer. Okay? So yung tangent, walang problema. Add or even, wala naman siyang problema. Pero yung secant, saka cosecant, make sure para masabi nating type 4, dapat even integer. So, again, ito yung identities. So, 1 plus tangent squared x equals secant squared x, and 1 plus cotangent squared x equals cosecant squared x. So, ano ba yung pinaka-concept nito? Ang pinaka-concept class, depende sa magiging problem. Example, evaluate the integral of tangent x to the 4th power times secant x to the 4th power dx. Ang unang ginagawa class dito, parehas dun sa sine and cosine, kailangan nyo pong mag-separate ng isang secant squared. Gagawin nyo po yun kapag tangent saka secant yung magkasama. Isang secant squared yung kailangan mong ihiwalay. Ngayon, anong purpose? Ang purpose po niyan, derivative. Yun ang pinaka-purpose. Parehas ito nung sa type 1 na may siniseparate. Kaya lang, sine or cosine. So dito po, sa tangent and secant, yung secant squared or yung even number, dito po, even number kasi yan. So, kailangan mong ihiwalay yung secant squared x. Ngayon, since ang secant squared x ay derivative, anong trigonometric function yung may derivative ng secant squared x? Diba? Tangent. Diba? Tangent x. So, it means, kung may nakikita ka pang another secant squared x, so, you need to use trigonometric identities. Kasi, derivative na to, dapat tangent po yung matira. So, ito, identity is 1 plus tangent squared x, then multiply, we have tangent x to the 4th power times plus tangent x to the 6th power times secant squared x dx. Then, this is just a power formula. Bakit? Kasi yung tangent, ang derivative ay secant squared x. There is no neutralizing factor kasi exact na po yung ating derivatives. It means we need to just add 1 to the exponent. Diba? Kaya meron na tayong integral na tangent x to the power over 5 plus tangent x to the 7th power over 7 plus c. So, kung mapapansin nyo, madali lang yung type 4. Basta, ma-identify nyo po yung type niya. Kasi according sa type, meron na pong solution tayo na gagamitin. Okay, so next example. What if we have this? Evaluate the integral of cotangent x to the 5th power times cosecant x to the 4th power dx. Again, ang binabantayan dito yung tamang combination na kapag cotangent, dapat talaga cosecant yung katabi niya. And dapat even number. Again, yung isa pong cosecant squared ay kailangan ihiwalay for the purpose of derivative. At yung natira na cosecant squared x is we have an identities 1 plus cotangent squared x. The same lang nung kanina, i-multiply. And then, if you observe, yung derivative po ng cotangent ay negative cosecant squared x. There is no neutralizing factor. So, therefore, mag-add lang tayo ng isa sa exponent nila. And ito na po yung magiging answer. So far, anong napansin nyo? Madali lang, di ba? Madali lang. So, basta meron po siyang, basta malaman nyo po yung different types. Okay, kaya yung dito po yung simple task, no, kung di pa kayo nakapag-solve, ito po yung recommended ko na masagutan nyo kasi itong mga tanong na ito is simply naka-base na ito dun sa 4 na types. So, kapag ka na-solve nyo ito, it means wala na din problema pagdating sa exam. So again, kung nalilito pa rin, so ang pinakakailangan lang dito ay more practice o di naman kaya magtanong na lang po kayo sa akin kung talagang nalilito pa rin. Pwede niyong ulit-ulitin yung panonood ng video. So hanggang dito lang to and thank you very much sa inyong lahat. Bye-bye!